Hi everyone, in this video we are going to discuss the atom, but before we dive deep into the atom and break it apart into its little pieces, I want to start with a big picture and start by talking about mixtures and break mixtures down all the way down till we get to the part of the atom. So let's start with mixtures. We discussed mixtures a couple different times now, so we know there's two different sections. We either can have a homogeneous mixture, which things are all one phase, or we can have a heterogeneous mixture, which has multiple different phases. Regardless, in order to have a mixture, by definition, you absolutely have to have two compounds. So I'm going to write 2 plus because you can have more, but you have to have at least two compounds. Now, what's interesting is we can actually take a compound and break that apart. And so for a compound, it is definitely comprised of at least two different elements. So I'm going to write 2 plus elements, and by definition, technically, they need to be different elements. So we can't just have a bond between two nitrogens. It needs to be a nitrogen and an oxygen, or a nitrogen and a fluorine, or whatnot. It has to be two different elements. Now, what's really cool is we can actually take elements and break them apart into atoms. Okay, so now atoms are the whole point of this video, so let's give a quick definition here. Atoms are considered the smallest unit of an element that can exist as a stable, next word is super important, independent entity. Okay, it can exist by itself. That is super, super important because that is something we can break it down into its finite pieces, all be into atoms here, but it is stable by itself. If you have a carbon atom, it will sit there as a carbon atom. So what I want to do is actually draw you a picture of what a very, very simple basic atom looks like. And in order to do that, we need to introduce three terms here. So now an atom typically has three different components. It's going to have protons, which are considered positive, and sometimes they write them out as P+. So those are always positively charged particles. Now, we can also have neutrons, which would have a neutral charge, so we would write a 0 there, and sometimes they're written like that, and these are considered neutrally charged particles. And then the last piece, which is my favorite piece because it has to do with most of chemistry, these are called your electrons. Electrons are typically negative, and they are typically written as E raised to the negative there. I use this notation all the time, so get very, very comfortable with it and know that that means electrons. So now, before I can do anything further, we need to absolutely get a picture of this. So we said an atom is created of protons, neutrons, and electrons. So let's draw a picture. So at the very, very core of an atom, we have the protons and we have the neutrons. So they are sitting at the core. Now, orbiting it somehow in some random direction, and we'll talk about this later, we have these electrons floating around on the outside. They are all on the outside. They are not inside the core. So the electrons are never in the core here, and the protons and neutrons are absolutely never on the outside. They're never orbiting. So we need to make sure we keep that distinction real. So let's talk about a specific example so make sure we're all on the same page. So let's look at carbon. Carbon is a great example here. So here is carbon. There's two things we need to look at. There's a 6 right here, which is going to tell us our number of protons. And then we can look at the mass below it, which is kind of hard to see on this periodic table right there. And that's actually going to tell us our number of protons and our number of neutrons. So if we were to write this out in a little formula, we would have a big C, because that's its symbol for carbon. We would put the bottom is our number of protons, so that's that part right here. And then we would put a 12 at the very top, which is your number of protons and neutrons. So we need to get very comfortable with this notation. So you do your symbol here, that's your letter. Below it is your number of protons, and then up top at the superscript is your number of protons and your neutrons. So now if I were to ask you to draw me a picture of carbon, all I could expect you to do at this point would say, give me a circle like this and say that you know for sure you have 6 protons in there, and then you must have 12 minus 6 to give you your number of neutrons, right? So you have 6 neutrons. And then I would also expect you to be able to, based on our last module, tell me how many valence electrons we have. You wouldn't really know that we have 6 electrons total yet. Maybe you do, maybe you don't. I don't expect you to know that. But what I do expect is that you would be able to tell me that carbon is in group 4. So we have group 1 here, 2, 3, And then carbon right here is in group 4. Group 4 means there are 4 valence electrons. So we know there's 6 total just because I just told you that. So we have to have 2 electrons somehow here on an inner shell. And then on the outside of this somewhere, we have to have our 4 valence electrons. Again, I don't really expect you to know this yet, but just start getting comfortable with the terminology and understanding protons and neutrons are in the core always, electrons are going to be on the outside pieces, and start getting comfortable with that periodic table and figuring out where are my valence electrons, where do they lie. Now, I want to move on and put a distinction between the words compounds and molecules, because that's one big thing that people are always interchanging, and they definitely mean different things. So the first thing we need to be on the same page of is that elements can share and transfer their valence electrons. This is a super important concept. This is how the whole foundation of chemistry is really based off of this. So elements can share and transfer their valence electrons with other elements. They can exchange it, they can share it. We'll get into that deeper. But right now we just know that they can share it. Now, here's the thing. We can either do this when you have 2 plus elements, okay, just in general, very, very, very vague, or we can do this when you have 2 plus different elements. When you have different elements, by definition, this is called a compound, okay? 2 different elements. You have a sodium and a chloride. You've come together. That is a compound. Now, a vague term, when you just have 2 elements that come together, that is called a molecule. So now if you had 2 oxygens that came together and formed a bond, that would be considered a molecule because it is one element even though you have 2 of them. But again, if you have a sodium and a chloride, that comes together. It's different elements. That is a compound. Now, let's see if we understand this. First question. CO2 is an example of and it's going to be either a compound or a molecule. So think of that, and then while you're thinking of this, we're going to write the second question right out here. N2 is an example of a compound or a molecule. Think about this, come up with an answer for each, and then submit your answer. All right, did we come up with answers for this? Hopefully this was super, super easy. Carbon dioxide has 1 carbon and 2 oxygens. By definition, that is 2 different elements that has to be represented as a compound. That's the only answer we can use for that. Now, N2. N2 has it has 2 elements, but they are the same element, okay? There's 2 elements, but they are the same. It is not a compound. We have to use the word molecule to describe that, okay? So we need to make sure that we understand the difference between these 2 words. The last thing I want to throw in here is what's considered a chemical formula. So now I've been using these things. So CO2, I've written N2, we've done NO2, we've done SO2, so on and so forth. These are all called chemical formulas. Chemical formulas are simply just a representation of elements, okay, that are existing. So it's the elements present, maybe that's a better way to say that, and this is very important, their, their corresponding ratios. So what's super important about that is what we can see here is that there's 1 carbon to every 2 oxygens for that one. For here, there's 1 nitrogen for every 2 oxygens. If I were to write out sodium chloride, you would tell me that there's 1 sodium for every 1 chloride. We absolutely have to be able to do this, and we really need to dive deeper into chemical formulas. So I'll see you in the next video.